Hi, in this video, I'll show a general approach to derivatives where you're expected to apply multiple derivative rules and formulas. So these are the rules of derivative. The first two rules are nice and the next three rules are not. And I want you to always think of them as two separate sets like that. In the first two rules, the derivative, think of it as distribute nicely. So for example, in the first rule, a constant factors out of the derivative and you can factor it out and then differentiate what's left. The second rule, the derivative distribute nicely across a sum. Now combine that with the first rule and where c is equal to -1, then you will also see that this rule also applies for subtraction. So it's a plus or minus. So whenever you have different terms of a function being added or subtracted, just break them up and do one piece at a time and then add and subtract them back at the end. That's the end of the nice rules. Everything else, you have to think there's a special rule for derivative, don't distribute. If you have a product, then you have to apply the products rule. Derivative first times the second plus derivative second times the first. If there's a quotient, you have to apply the quotient rule. There's a division, you have to apply the quotient rule. So first, don't forget the g squared. And second, how do you remember what comes first in the numerator? Remember, the numerator has a minus sign, so it does matter which way you do it. And the way I remember it is that f is the numerator. It comes first in the fraction, so it also comes first in the derivative. And finally, the chain rule. The chain rule is super important. Almost every derivative you see in your calculus class, in your later calculus classes, in all your math classes and the science classes and engineering classes, if there's going to be a derivative at all, it will have the chain rule to go with it. So the chain rule is the most important rule of all. In addition to those rules on how to manipulate a derivative, you need the basic formulas on what the derivative is equal to. The most basic formula is the power rule. If you have x to the a, where a is a constant, in other words, it does not work if you have an x in the exponent. Then the derivative of x to the a is a times x to the a minus 1. A specific application of this is that the derivative of c times x, where c is a constant, is just equals to c. So the derivative of 3x, for example, is just equal to 3. And finally, also an application of the power rule, derivative of a constant is equal to 0. So if you have something like minus 19, then derivative of that is just 0. If you're in a calculus class that is so-called late transcendental, the power rule is pretty much the only formula you need for a while. If you're in a class that's early transcendental, you will also need to know these following formulas. For exponential and log, derivative of e to the x is e to the x. Derivative of ln of x is 1 over x. Next set of formula are the trig formulas. And the three that's on the left, the sine, cosine, tangent, are the main ones. Secant, cosecant, cotangent, they're more rare, they are not so common, but you need to know all of these. Remember, the secant is 1 over cosine, so I write the derivative of tangent and cotangent in both forms, because if you're going to have to enter the numbers into your calculator, chances are your calculator doesn't have secant and cosecant, so you have to convert secant into 1 over cosine and cosecant into 1 over sine. Inverse trig, one way to remember is that they come in pairs like this. Inverse sine, I write it as arc sine. A lot of people would write it as sine inverse of x, which is what a lot of calculators use. So the derivative of sine inverse is 1 over square root of 1 minus x squared. And the derivative of cosine inverse is minus whatever the sine inverse is. The derivative of arc cosine is minus the derivative of arc sine. The derivative of arc cotangent is minus the derivative of arc tangent. And the derivative of arc cosecant is minus the derivative of arc secant. So you really only need to remember the formulas on the left and then sort of like put a minus it for the ones on the right. Of all these formulas, the one that's actually most likely to show up later on in your career is the arctangent. There's a reason for that, but you'll see. All right, here's the general approach to doing a derivative problem. First, if it's several terms being added or subtracted, break them up because of the first rule, the rule that says f plus g prime is equal to f prime plus g prime, plus or minus. So because we can break them up, let's break them up. And then for each of those terms, do the derivative from the outside in. What do I mean by do the derivative from the outside in? This will make sense to you after you've done a couple examples, but let me clarify it right now so we can get started. That means that for each term, first you look at the main calculation in it. If it looks like something times something else, then that makes it the product. Then apply the product rule. If it looks like something complicated, divided by some other complicated things, then that makes it a quotient. Apply the quotient rule. If you don't see a product or a quotient, it's just one big function. For example, it's like one big cube or one big sine of something. Then just apply that formula. If you see something cubed, then just apply the formula, put the 3 in front and cut this down to a 2. If you just see one big sine of something, then the derivative of it's going to be cosine. So if it's just one big function, then apply the derivative formula for that function. But always watch for the chain rule. In your college career and in your professional career, if ever you need a derivative, it almost always requires the chain rule. All right, let's do this example. Let's say you're supposed to do this derivative. It consists of a fraction minus a power plus a constant. First thing you do is to break it up into 3 pieces, 3 terms. Take the derivative of first term minus derivative of second term plus derivative of third term. For this third term, a constant derivative of constant is just equal to 0. So that's gone. We don't have to worry about it. Let's now do the other 2 terms. Let me do this one first because it's easier. So the second term is 2x minus 1 to the power 6, derivative of that. What is it? Is it a product, a division, or a single function? Not a product, not a division. It is a single function. It's the power 6. Since it's a power 6, I apply the formula for power. This is the formula for power, where this here is my A is equal to 6. So the way I visualize doing the power rule is that I visualize that the 6 goes in front, the A goes in front, and then I also subtract it by 1. So the 6 goes in front, and I also subtract it by 1. And then I copy down what's here. Am I done? I'm not done, because going back to this slide, it says always watch for chain rule. always watch for f of g of x. Always watch for whether there's something going on inside the parentheses. Yes, there is something going on inside the parentheses. So I have to apply the chain rule. I have to multiply by the derivative of the inside. That's what the chain rule says. I take the derivative of outside the f. Then when I'm done with that, I make sure I multiply by the derivative of the inside, the g. And then if there's something inside of that, I multiply by the derivative of the inside of that as well. Some people say do it like you're peeling an onion. You get one layer out, and then you differentiate the inside, and then the inside one layer at a time. All right, so this is 6 times 2x minus 1 to the 5th times the derivative of this. Derivative of this breaks up into the derivative of 2x minus the derivative of 1. Derivative of 1 is 0, derivative constant. Derivative of 2x is 2. Back to this slide. It's the general power rule, but if you apply it to the case where a is equal to 1 and a equals 0, you will get the next 2 lines, and they come up so often, it's more convenient to just think of them as new formulas. The derivative of a constant times x is just that constant, and the derivative of a constant is just 0. Back at this slide. This is equal to 12 times 2x minus 1 to the 5th. All right, so I'm done with the second term. I put it here. It's 12 times 2x minus 1 to the 5th plus 0, and there's a minus sign here. Now I move on to the first term. What is the main calculation here? Is it a product, a quotient, or just a single function? It's a quotient. There's a division right here. So if it's a quotient, I have to apply the quotient rule. Here's the quotient rule. F is this numerator, and G is this denominator. I need the derivative of F, that's 8x plus 1 prime times G. Then I need minus f g prime minus f g prime 3x minus 2 prime. The whole thing divide by g squared. G squared is 3x minus 2 squared, like that. So from the outside in, the outside is a big quotient, so I apply the quotient rule. And now I go into the detail. There's the derivative of this, and there's the derivative of that I need to take care of. Derivative of 8x plus 1. Derivative of 8x is just 8. Derivative of 1 is 0. So derivative of 8x plus 1 is just 8. Times g minus 8x plus 1 times derivative of 3x minus 2. The derivative of 3x is 3. Derivative of 2 is just 0. Derivative of the whole thing is 3 minus 0 equals 3. Divide by 3x minus 2 squared. Multiply this out. 24x minus 16 minus 24x minus 3. The 24x cancel, and I end up with negative 19 on top and the denominator. There's nothing else to simplify, so I can put this in my original problem. So here is negative 19 over 3x minus 2 squared. And I box this up. I don't need the plus 0, so that's my answer. Moving on to another example. Let's take this derivative. E to the negative 2x times the square root of x squared plus 1, the whole thing, take the derivative of. Step 1. Look at the main calculation in it. Is it a product, a quotient, or just one function? The main calculation is a product. There's a multiplication here. There's a multiplication between the exponential and the square root. So it's a product. I need to apply the product rule, where I have the multiplication right here. This is my f, and this is my g. So apply the product rule, derivative of first term times the second term, plus the derivative of the second term times the first term. Okay, this is my f prime g, and this is my f g prime, plus. Okay, let's do one at a time. Let's do this. What is the main calculation in that little piece? Is it a product? No. Is it a division? No. Is it a single function? Yes, it's a single exponential function. So I apply the exponential formula. Derivative of the x is e to the x. So I have e to the same thing again. But I must always watch for chain rule. Is there something inside my exponential? Yes, there's this thing that's inside my exponential. So the chain rule applies. I need to multiply by the derivative of the inside. All right, copy down everything else. E to negative 2x times this derivative. I'm going to leave this blank for now because I need to finish this derivative. What's the derivative of negative 2x? Negative 2. All right, so I'm done with that side. Now let's take care of this. What's the main calculation here? Is it a product? No. So no need for product rule. Is it a quotient? No. So no need for quotient rule. Is it a single function? Yes, it is a single function. It's a square root. I don't have a formula for square root. So I need to turn it into something I do have a formula for, and that is a power. I need to turn this into x squared plus 1 to the power 1/2, and I take the derivative of that. Now it's something I know. I know it's a power rule, so apply the power rule. The power rule says bring the exponent in front and at the same time subtract it by 1. So I bring the exponent in front and I subtract it by 1. But also, what else going on? What else is going on is that I need to worry about the chain rule. Is there anything inside the square root? Yes, there's something inside the square root. There's the x squared plus 1, so I need to take the derivative of that. The chain rule applies. The derivative of x squared plus 1, this is a power, so it's 2 times x to the 2 minus 1, which is just 1, so I don't need to write anything. And then plus 1, which is plus 0. All right, now let's simplify everything. E to negative 2x times negative 2 in front, square root of x squared plus 1, plus e to negative 2x times 1/2 times x squared to the negative 1/2. That means 1 over square root of x squared plus 1 times 2x. And then these cancel. So let me write my final answer over here. Minus 2e to negative 2x square root of x squared plus 1 plus e to negative 2x times x over square root of x squared plus 1. I can box it up like this. Some people like to do some extra algebra. Let's say they factor out the e to negative 2x. They may try to do common denominator, but I'm looking at it and I don't see any advantage from that. You could factor out the e to negative 2x, and then you end up with like this. So you could write in this form. And you can also take common denominator. Any one of these three is a good answer. All right, I hope that helps. So I'm going back to the general approach, break into terms being added or subtracted. And obviously at the end, don't forget to put them back together. And then for each term, do the derivative from the outside in. That means you look at the main calculation in it. Is it a product? Apply the product rule. Is it a quotient? Apply the quotient rule. If it's not a product or quotient, if it's just a single function, then you apply whatever the derivative formula is applicable to that single formula. It could be a sine, cosine, e to the power, or it could be just some x term to a constant power. Whatever the derivative formula applies, do that. But always, 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 always watch for the chain rule. Always multiply by the derivative of the inside. Hope that helps. Like, share, and subscribe for more contents. Thanks for watching. Bye.